because graphs are so widely used in the real world, I want to take a look at a real-life example. We have Sally. She runs a landscape service business, and the table shows her schedule. That for landscape services, if it takes 1 hour, price is $8, 2 hours 14, 3 hours 20, 4 hours 26, 5 hours 32, 6 hours 38. And we want to know, why is this data set linear? Well, if we take a look here, from 1 to 2, oops, this is plus 1, 2 to 3 plus 1, 3 to 4 plus 1, 4 to 5 plus 1, and 5 to 6 plus 1. And then 8 to 14 is plus 6, 14 to 20 is plus 6, 20 to 26 is plus 6, 26 to 32 is plus 6, 32 to 38 is plus 6. So we can say that this data set is linear because the rate of change is constant. Now, one might argue that if we went back to 0 hours, it would be at plus 2. Remember, just because it doesn't go through 0, 0 doesn't make it nonlinear. Now, the slope of the line that passes through this point, that's the beautiful part of calculating the rate of change. Therefore, this is 6 over 1, which we want to put a label with this, so it should be $6 over 1 hour. Now we need to graph this data. So if we look here, we have 1, 8. We have 2, 14. 3, 20. 4, 26. 5, 32. And 6, 38. And then we can go ahead and draw in our linear path, which, as you can see, crosses just before the 0. And we want to estimate the cost for 9 hours. And like it says, estimating. So if we were to take our line and extend this out, and then match it up with the 9 hours, that crosses right about here. So we look here, we'd be about 45, 50, 55, so about $57. Now if we actually figured it out, 7 hours would be at 44. 8 hours would be at 50. And 9 hours would be at 56. So when we said 57, that would be a good estimate. Alright, so next, I want to take a look at one more example. We have Sally. Her cash register contained $150 when she opened the store. And after 8 hours, the cash register contained $400. We want to find the average sales per hour and graph the line. So we have, remember, the change, which the triangle means change in f of x over the change in x. Our change in x is 8, because it's over the course of 8 hours. And we have here our change in f of x, which I'm going to draw a line over here since I ran out of space. We have $400 from 150, so to find the change we're going to make our difference, which in our case is $250 over 8 hours. So if we simplify this down, 8 goes into 25 3 times. That leaves us with 24. 1 left over. 10 goes into 8, or 8 goes into 10 once. That's 2 left over. And then 8 goes into 20 twice, which has 4 left over, and 8 goes into 45 times. So this is $31.25 in money per 1 hour. This is our average sales per hour, and so now we need to graph this line. So time always goes on the bottom. Think of a timeline. Timelines run horizontally. And on the side we have sales. I'm going to put that in money. And time is in hours. We want to put a title on this. Sally's store. Sales. And we want to number our number line. So I am going to go every 2 is going to be $100. So here's 100. Here's 200. Here's 300. Here's 400. Here's 500. And we can stop there since our numbers don't go above that. Then when the store opened, she had $150. So that means at 0 times 0, she had $150. I'm going to go then back to my blue and put my time every 2 represents 1 hour. So 2, 3, 4, 5, 6, 7, 8. And so then we have our next point was that after 8 hours there was $400. I apologize for the delay. I was having an issue with the iPad. So there we go. And because we're assuming this is linear, and there is your graph. Your job now is to go ahead and complete these 2 problems, graphing the functions, and bring them to class with you tomorrow.